Hello and welcome to the University of Dundee Open Day. I'm Robert Keach and I'm going to be taking you through the degrees in Mechanical Engineering and Mechanical with Renewables. So I belong to the School of Science and Engineering, and as you'll see from the next few slides, I'll show you the structure of our school, where the programs sit, and the kind of things you can expect to be doing if you come to Dundee to do one of our courses. So first of all, unfortunately, you can't join us today and come to the university on campus, but hopefully some of the slideshows and videos that have been posted today will give you an idea and a flavour of the kind of things you'll find at Dundee. We're on the east coast of Scotland, about an hour from Aberdeen and Edinburgh, about an hour and a half from Glasgow, and we're the fourth largest city in Scotland. Very vibrant city, lots to do, and 5 minutes in every direction you find yourself in the middle of the countryside. So as I say, it's a vibrant student city. About 14,000 students are on campus during normal term time. Very good affordable living here, with about 40% cheaper than the UK average, and currently undergoing a huge waterfront refurbishment with the V&A here and lots of new art and design galleries and things propping up. So the structure itself, the School of Science and Engineering sits within one of 10 schools at the university. What you'll see here is I put it in the centre. We do everything from School of Arts and Design all the way down to School of Social Sciences with things like business, dentistry, medicine, education, humanities, nursing and life sciences. And why I put us in the middle is because we're very much a central part and like a hub to work across all the other schools. And you'll see specifically in engineering, that's what we do. Engineering is very much problem solving, so problems and issues and research that comes from lots of other schools end up often with engineers sitting solving. So this is something straight away that you can see you'll be part of. If we go down another section then into the actual school, the school itself is made up of 7 discipline areas. These contain many programs, but here you can see again the typical ones you'd expect in science and engineering, maths, physics, computing, civil engineering, biomedical engineering, mechanical and electronic engineering, and then CAHID, which is again an unusual one. It's the Centre for Anatomy and Human Identification. And again, it shows the kind of interdisciplinary, multidisciplinary nature of our university and the way we can work across disciplines. So in this case, we would work with forensic scientists, solving crimes, looking at crime scenes, and also looking at medical implants and things that can be used within anatomy. So quick breakdown of the actual programs itself. You can see here we have on the left of the blue the undergraduate programs, and on the right in the red the postgraduate programs. What we do is a 4-year course in mechanical engineering, a BEng in mechanical engineering honours, also a BEng in mechanical engineering with renewables, along with a BEng in electronic engineering, which currently is under review. And rather than an MEng, which would be a 5-year course, we tend to run 1-year MSc courses at the end. So within a 5-year period, you'd end up with a BEng honours undergraduate degree and an MSc, which is a higher postgraduate degree. And of course, that 1 year in the MSc could be done at any university and is a very specialised course. So I'll show you a few of the ones that we're doing at Dundee. You can see from here we have industrial engineering with management, industrial engineering, and international finance. So a little bit more detail on that in a minute, but here we have it again in a bit more structure. So the BEng in mechanical engineering is an honours degree, but it can also be an ordinary degree, which is after 3 years you can leave. The same with our mechanical engineering with renewables course. We also run a BEng in engineering design and manufacture, which is run as a graduate level apprenticeship. And that again is run for 4 years, but this time it's done in association with a company. So you're an employee of a company and they will release you 1 day a week to go into university to get your honours degree. So a slightly different experience than a full-time student because you'll be working with a company, but then the benefits of that are you've got employment throughout the 4 years, probably no need for a student loan, and you've got a guaranteed job at the end of it. But as I say, it's a full year for 4 years rather than a semesterized term that we run for the normal undergraduate programs. The postgraduate programs I've already mentioned. The top 2 here I've already shown you, the MSc in Industrial Engineering with Management and Industrial Engineering with International Finance. They are 1-year courses starting in September, and there's another intake in January. They all have associated with them a 12-week placement in industry. So this is a perfect opportunity at the end of your degree to test the water for companies. So work with a company for 3 months, and at the end of that, often the students will stay on as full-time employees for that company. But that's in association with the business school. We do some of the modules with the business schools on entrepreneurship and management. And as you can see here, we've got some new pathways which are coming on board in 2021. So these are entrepreneurship, digital marketing, and we're discussing currently about renewable energy. We have other programs linked to the medical school, so if you're interested in applications such as implants and surgical devices and such like, then a degree maybe in an MSc in biomedical engineering or medical imaging would be something you could do at the end of your mechanical engineering program. So again, these are all options after you've done your 4 years of undergraduate studies. Going then in detail on the actual program itself, you really want to know what's on the course. Well, the first 2 years are pretty common. They're general engineering courses covering maths and physics, the same kind of things you'll do in many universities in an engineering program, but more specialized in projects. So we do a lot of lab-based learning, working together in teams, making things, discovering things, building, manufacturing, and so on. And that gives you the kind of skill set we need for problem solving and what makes a good engineer. Right the way up to the end of second year, there is a flexibility to change between programs. So if you're finding that mechanical renewables or biomedical or civil aren't the ones that you want to do, you can swap between them without any penalty, providing you've passed all your exams. So that gives you a little bit of flexibility at this stage if you're not sure which exact engineering discipline you want to pursue. By the time you get into third year, then it's a much more specialized degree, so you can't then transfer, and then you can, as I said earlier on, leave at the end of third year with an ordinary degree. Our fourth year then is the classified honours degree, and that is really a very research-based year. You get to choose your own project, and you'll undertake that project for a whole year. And I'll talk a little bit about some of the projects that people do in a few slides' time. We also have a 5-year accredited degree which allows you to take a year out in industry. So between years 3 and 4, you can spend a whole 12 months in a company and then come back and finish your degree. At the moment, we've just received funding for what's called the Turing Mobility Scheme, which allows students to go to CERN, which is where the Large Hadron Collider is, and to work there for 12 months between your third year and fourth year, and then return, as I say, at the end of that fourth year to continue with your honours degree. So lots of good opportunities to become very good engineers. And then finally on here, the physics and maths is used to help engineers solve problems. The question I constantly get asked, depending on how you've done at school, whether you like physics and maths, what you'll soon learn is that these are just tools to help engineers solve problems. So maths is very much a language, physics is lots of equations and applications in mathematics and physics, which then lead into engineering itself. Okay, that leads us on to the drive team. So one of the things that people often love at Dundee are the societies, and one of the societies that is run out of mechanical engineering is the drive team, where it's to do with the Formula Student Competition. The IMechE run this. It's a chance to design, build, and then drive your own 600cc racing car, which you can take down to Silverstone after the British Grand Prix in July. And we have a very successful team that's been doing this for a number of years. So if you're interested in that, certainly you can join that from the get-go. We do a lot on design and manufacture, as you can see from this slide. So things like CAD imaging, and then emulating and rendering these, and then simulating them to see how they would work if they were put into a machine. We do 3D printing as well, and you'll be doing that from the get-go. In fact, the first year students all actually get to build a 3D printer and then see how that works. I want to quickly move on to one of our very popular degrees in mechanical engineering with renewables. Evidently Scotland and Dundee specifically are centres for renewable industry with the policy now, climate change policy, to look at zero carbon emissions by 2045, which is 5 years ahead of the rest of the UK. Scotland's already ahead in this game. Lots of onshore and offshore wind farms. Solar PV was invented at Dundee University actually back in the 60s, and evidently hydro and wave power are also two big areas of interest. So this is really an emerging technology, and lots of jobs in this industry are now looking for engineers rather than the oil industry, now in the renewable sector. And with COP26 now at the forefront of what's happening this year, the Conference of Parties coming to Glasgow in November, it's an international kind of focus on zero carbon emissions. So I mentioned wave energy, and Scotland again is very well positioned for this, with one of the environmental factors of 10% of the wave energy from Europe actually passing over the coasts of Scotland. So certainly on the west coast, there's centres for development in Orkney where they're looking at new technologies for harnessing this energy, either from underwater with things like on the seabed, they'll have things like turbines, to on top of the water where they can kind of harness that energy from the waves. So this again is an industry which we're developing technologies all the time and you can very much be part of. And finally, solar energy. So through solar PV photovoltaics, which as I said earlier, were invented in Dundee University in the 1960s in the physics department. Dundee being the sunniest city in Scotland with more daylight hours than anywhere else. So again, a very fortunate place to work and develop these new technologies. So this is something, again, you can be involved in to meet this kind of 2045 zero carbon emission that Scotland set for itself. I've talked about applications in engineering, so medical applications is a big one. So we have Ninemores Teaching Hospital in Dundee, which is the largest teaching hospital in Europe. And again, applications for you to work on problems associated with healthcare, anything from robotics to implants and prosthetics and surgical devices. These are all things that we can do as mechanical engineers if you're interested in the medical application. And that also leads to the biomedical. As I said, we do an MSc in that. We also have an undergraduate degree in it. And this allows you to apply the design and problem solving skills of your engineering to the world of medicine and biological sciences. And I've already talked about CAHED and the use of research on studying forensics. So looking at crime scenes and then using physics and engineering principles to basically solve where blood spatter comes from, the blunt force trauma, ballistics and bulletproof vests. We do all that as part of our engineering degree, and it allows you to, again, apply your knowledge to areas that you may be interested in. And then back to CERN again. So CERN, we are the only Scottish university to have a partnership with CERN. This is the world's largest experiment based in Geneva. It's about 28 kilometers going underground all the way into France and back again. And we routinely send students out to CERN as part of their honours year to do projects working with the engineers based there. And as I said earlier on, we now have a one-year placement which is being funded by the Turing Mobility Scheme to allow you to go out there fully funded and work within the labs. So again, this is a great opportunity for students to take that further. If you're not interested in that, there's other aspects. We have industrial placements and we have industrial visits all the way through the 4 years, allowing you to see local companies and some big international companies, and again, see the kind of problems that you'll be facing when you're fully graduated. So, a bit on the global experiences, just to show you the kind of opportunities that are available to you when you come to Dundee. So first of all, I've talked about this one-year placement in industry. So it's a 5-year accredited course. Between years 3 and 4, you can take a year out, and that can be anywhere in the world. We're doing the Erasmus exchange still, although Brexit is now kicking in. We still have funding to allow students to take a term or a year in one of the European partner institutes. And again, all we do is marry the modules that you're doing with those in another institute, and that allows you to then study abroad. And if you want to go further afield, there's global exchanges with some with countries such as America, Australia, New Zealand, Canada, and China. China is one of our biggest partners now, sending a lot of students to Dundee in their final year. So with that, we have summer schools going out to China, learning some of the culture, and evidently a good opportunity to see some of the big international companies that have set up there. One of the things we really pride ourselves at Dundee with is the fact we have a gold award in teaching excellence. It's called the TEF, Teaching Excellence Framework Award. And that's because we really do pride ourselves on giving the students good experience. You know, you're not just a number, you are a person, and within the time you're at the university, we want to make sure you get the best possible education, learn from us, and then go on and use all the techniques and things you've learned when you go into industry as a career. So that's just a very short intro today to the Open Day. There's a number of other videos that are going to be posted online for you to see. Some views from the students themselves. There's going to be a question and answer session, and then a bit more details about the program content, which my colleagues will be delivering. But I would like you to follow us evidently with our Twitter and Facebook accounts. I mean, lots of good information there over the next year before you make up your mind whether you're going to be coming to Dundee. And again, we'll be running similar post-application visits next year once you've put in an application to see us. So thank you again for your time, and I hope you've all enjoyed today looking at some of the great videos that have been posted. And if there are any questions, please post them in the chat room below. Bye for now.